Hi guys, in this video we're going to be looking at how we can add and subtract algebraic fractions. This topic can be a bit tricky because it involves adding, subtracting, multiplying, simplifying fractions, adding like terms, subtracting like terms, a bit of expanding as well. So it's a good wrap up of all the stuff that we've done in algebra so far. And once you get the process down though, it should be fairly basic. So if two fractions have the same denominator, then adding and subtracting is very easy. We simply just add the two numerators or subtract the two numerators, keep the denominator the same, easy peasy. But what we're really focusing on is if the fractions don't have the same denominator. So however, if the denominators aren't equal, we can then use what we call the Smiley Sam method. Why is it called Smiley Sam? Well, looking at this little example we have at the bottom, we see that the process is we multiply the two denominators. So 2 times 3 is 6. Then we do the top left times the bottom right, which is 3x. The bottom left times the top right, which is 2x. And we see that these little, the little red arrows kind of make a little smiley face. That's why we call it Smiley Sam. But then looking at what we do from there, we then 3x plus 2x equals 5x. And there we go. So let's just jump right into a few examples. So this first example, we have 2x over 5 plus 3x over 4. So straight away, we see that the two denominators are not the same. If they were, we could just add the two numerators and call it a day, but they're not. So instead, we're going to use Smiley Sam method. First off, the first step we need to do with Smiley Sam method is we always multiply the two denominators together. So 5 times 4 equals 20, and that becomes our new denominator. So we have 20. The next thing we do is we do the top left times the bottom right. It's always that order, top left times bottom right. So 2x times 4 equals 8x. And then to finish up, we do the bottom left times the top right, and there's our Smiley Sam. So 5 times 3x equals 15x. And now what we do is just simplify our numerator. 8x plus 15x equals 23x. So that we'll just be left with 23x. 23x over 20. And we can't simplify that any further because 23 and 20 do not have a common factor. So that's our answer, 23x over 20. I'll just bring that down. All right, going into the next example, starting with the same idea, the two denominators aren't the same, so I'm going to have to use Smiley Sam. I'm not going to say that from now on, we'll just assume it. So first step is multiply the two denominators, 7 times 6, so 7 times 6 equals 42. That's our new denominator. Then we do the top right times the bottom left. As I said, it's always in that order. 4x times 6 equals 24x. And then we do the bottom left times the top right. 7 times 5 equals 35. Just note, though, we are doing 7 times negative 5, or we realize that we're minusing here, so we're just going to do minus 35. And then we have that. Now, the last thing is, if we're looking at the 24x and the 35, we see that they're not like terms. So because they're not like terms, we can't simplify that. And that there are no common factors between 24, 42, and 35. So that's actually our answer. We can't simplify that any further. So just by doing the Smiley Sam, that's the end of the question. 2 more examples. And we see that in these 2 examples, we have 2 terms in the numerators. So that means we're going to be treating them with brackets. But let's start off with our Smiley Sam. Multiply the two denominators. 4 times 3 equals 12. So that's going to be our new denominator. And now we do the top left times the bottom right. And so how we're going to write this, we need to do the whole x minus 2 times 3. So we'll write it as 3 times x minus 2 with brackets. And as you see there, we're probably going to end up expanding in a second. And then we can just do the same going this way. So this would be plus 4 times x plus 1. So next thing we want to do is then simplify that numerator. And to do that, with expanding these brackets, first of all, we're going to do 3 times x, which equals 3x, and then 3 times -2, which equals -6, then 4 times x, which is plus 4x, and then 4 times 1, which equals 4, and that's over 12. Last step was to simplify that numerator. So let's add the like terms. 3x plus 4x is 7x, and then -6 plus 4 is -2, and that's all over 12. Looking at our 3 terms we have left over, 7x, 2, and 12, there are no common factors between each of those numbers, so we can't simplify that any further, and there's our answer. So to recap on this question, we see that there was multiplying, there was adding and subtracting, there was expanding brackets, there was simplifying. As I said at the start of this video, it's kind of a recap of all the skills that we've been doing in algebra over these past couple of videos. Let's just do this last question. So starting off, first step is we've been doing, multiply the two denominators. 2 times 3 equals 6. That's going to be our new denominator. Then we do the top left times the bottom right. Again, because we have 2 terms in that numerator, we kind of treat them with brackets. So we have 3 times 3x plus 1. And then one thing we need to note, there's a minus here again, so we're going to have the right -2 because we're doing bottom left times top right. So we've got -2 times 4x minus 3. And we're going to have to keep track of that negative because when we're expanding in a second, we're going to be multiplying by negatives. So next step we need to do is we need to expand these brackets. 3 times 3x is 9x, 3 times 1 is 3, and then expanding the second brackets. -2 times 4x is -8x. And then -2 times -3, we have 2 negatives there. So as we know, multiplying 2 negatives makes a positive, so that's plus 6. And we have that over 6. And last step, let's just simplify it. 9x minus 8x is just x. And then 3 plus 6 equals 9. So this is plus 9, and that's over 6. And there's nothing we can simplify. There are no common factors of 1, 9, and 6, so we don't do anything else to that. So that's a video on adding and subtracting algebraic fractions. It's a recap of lots of stuff we've done, but if you've been good with all that, this should be good as well. Have fun.